Hi. Uh, Today's video we're going to discuss about another framework, Java related framework for YouTube. So I'm going to discuss about OpenCV. OpenCV is an open source computer vision library for programming functions, mainly real-time computer vision. OpenCV is basically developed for real-time computer vision. Originally developed by the Intel, it was later supported with Windows Garage. OpenCV, I have used this in a couple of programs in Java. If you want to take build a camera, you want to take a photos, you want to take a pictures, any vision related application, computer vision related applications, right? OpenCV would be very useful. So you can use this, advanced vision research by providing not only open but also optimized code for basic vision infrastructure for any vision based applications. Okay, you can use OpenCV. OpenCV is a very good framework. You can use this OpenCV. You can see the first alpha version of OpenCV was released in public at in 2000. After that, betas was released in 2001, 2005. First version released in 2006. Okay, that way, in August 2012, support for OpenCV was taken over by the non-profit foundation OpenCV.org, which maintains the developer and user site. You see, so many applications are there. You can see how the OpenCV can be used. OpenCV application areas basically include 2D, 3D features like toolkits, okay, ego motion estimation, facial recognition system, gesture recognition, human-computer interaction, mobile robotics, motion understanding, object detection, segmentation. Natural language, text processing is very easy. We have many applications, so many libraries are there. But related to the computer vision, there are very fewer libraries. That too, open source libraries are very few. So one of them, OpenCV, is a very good framework. As I told you, you want to take a video or you want to build a camera, you want to take a motion video tracking, structure from motion, object detection, photos. Okay, so many applications. I'm just giving examples here. To support some of the above, OpenCV includes a statistical machine learning library that contains boosting, decision tree learning, gradient boosting, expectation maximization algorithm, k nearest neighbor algorithm, artificial neural networks, random forest. You can see so many in so many applications. OpenCV is going to be used. It includes a statistical machine learning library. Okay, its support is required. Even deep neural networks, you can see deep neural network is a very advanced topic in artificial intelligence, in the area of artificial intelligence. Whenever we are going to build a neural network, we are going to train a model, we are going to build some model based on some parameters, we need to understand the neural network. Okay? And we need a statistical machine learning library also sometimes, to improve that, to improve the model, to build a proper neural networks. So OpenCV, it can be used anywhere because it is a vision related framework, right? Computer vision related framework. For example, simple example I'm telling you, you want to read a human face and you want to identify the person based on the face recognition. How do you do that? You can use the OpenCV. You want to identify the object. You want to convert a particular object into text. You want to decipher a particular data from the particular photo. You can, particular image, you can use for all those kinds of use cases. OpenCV would be useful. You can use that. There are so many computer vision related libraries are available in the market, but the thing is, OpenCV is the standard open source. Okay, OpenCV is written in programming language C++. We all know C++ is a very good programming language. It has been everywhere. We can use the C++ for writing compilers, for writing operating systems, for writing embedded software. We are going to also use that in NASA. In so many areas, C++ is very good for system level programming, right? You can never imagine any area without C++, because underlining things were built by C++ programming. So in the same way, OpenCV was written in the programming language C++. Its primary interface. There are language bindings in Python, Java, MATLAB. So many things are there. Okay, OpenCV is a very good thing if you want to use it in code. That's all about the OpenCV. I hope you understand the main significant advantage of the OpenCV. Let's go and do some other. Let's check another thing here. Platform for continuous inspection of code quality. Have you ever heard about the Sonarqube? We use the Sonarqube for code quality. What do you mean by the code quality? So whenever the developers are going to write a lot of code, they're building applications, so the code needs to be analyzed, the static analysis of the code. What do you mean by static analysis? Whenever people are building something, or developers are building something, there are a particular set of standards as per the Java programming, right? There are some rules, constraints, policies. There are some standards set by every programming language. So these are all the static standards, right? So whenever particular code base is going to is not going to meet the particular standards of particular programming, then it will be a problem. We can face many bugs, errors, issues, right? If some code is not following particular standards of the programming language that are set and designed by the programming experts who actually invented and written the programming language, because if you do not follow those the standards, it will result in the bugs. It may result in the memory overflow issues. It may result the performance issues. It may result some other security issues. So many issues may come into the picture. So as part of the code review, the first thing every developer, every team, every IT company, what they will do, they will first perform the static code analysis. Evaluating each and every line of the program with respect to standards, policies, constraints. They are all static rules, right? They will verify each and every line of coding as per the policies, rules, constraints, standards. If they are going to deviate or something is not written as per the expected scenario, expected static code, expected rules, then we call it as a bug. They are deviating from the standards. Then immediately we have to remove those we have to refactor that code. We have to remove those bugs. So we have to restructure the code again. You see, avoiding the duplicate code, making sure the coding standards are there, unit test, code coverage, technical debt, code complexity, comments, bugs. So many issues will be there. The Sonarqube is a software. It can be used as a static code analyzer. When you complete the code, right? When you complete the code, we will submit our complete code to the static code analyzer. What it will do, it verifies the code. It verifies the number of lines and codes, and then what it will do, it will check each and every line, and then it will report if any bugs are there, if any deviations are there. Some people, they write the code in a simple way. They don't care about the exception handling. They don't care about memory issues. They do not care about dead code, duplicate code, the code which is not a proper, the code which is not readable, understandable. It is all against the coding standards. So Sonarqube will identify these things in the early stage and will report that in actually static code analyze the report. So these are the advantages of the Sonarqube. Basically, Sonarqube is a static code analyzer. First we need to set up a server, and then we have to define, we can also define the custom rules for the Sonarqube when you are setting the Sonarqube, and when you submit your code for the Sonarqube, it will actually give us a report. It will specify the report. It can specify the errors, bugs with respect to the priority and severity. Based on that, we can actually take care of the issues. So these are the important things regarding the Sonarqube. I hope you understood this Sonarqube concept. Okay, and what else? I'm going to explain the Java frameworks. All these are Java frameworks. I'm trying to explain randomly. You can see here, SL4J, simple logging facade for Java servers as a simple facade abstraction for various logging framework. SL4J, everybody knows about it. Is a logging framework, right? You can see here it is a logging framework. Java logging API by means of simple facade pattern. You can see here we can actually use this. You see, maybe the standard Sun Java logging package, java.util.logging or log4j, reload4j, logback, underlining logging backend is determined at runtime by adding the desired binding to the class path. So simple logging facade for Java 4j. So similarities between with log4j. Log4j is one of the logging framework. So in the same way, you can use SL4j. You can actually provide this logging information. You can see here, simple. You can actually provide the debugging, tracing, errors, exceptions. You can see all this stuff here. SL4j would be helpful for you if you want to do that anything. Okay, now what else we want to discuss here? Spring Security, authentication and access control framework. We need to discuss about the Spring Security, because Spring Security is a very complicated framework. For understanding it's complex. So once you understand this, Spring Security is a very good security. Even for enterprise level applications also, you can provide the Spring Security. Most of the enterprise applications, they are still using the Spring Security, because Spring is the dominating framework nowadays. Spring Boot is advanced, and along with the microservices, Spring teams are building the APIs. Okay. I hope you understood this video, and thank you very much. We can discuss further later.